Dear students, welcome to the world of chemistry. Chapter 4, Chemical Bonding and Molecular Structure. This is the e-content lesson number 9. Students, learn chemistry in a simple way. Let us start. Today, we can learn about Chapter 4, Chemical Bonding and Molecular Structure, an important topic, Valence Bond Theory, VBT, the directional properties of covalent bond and overlapping of atomic orbital. See the pictures of hydrogen molecules forming covalent bond. Picture 1, separate hydrogen atom. What does it indicate? No interaction between hydrogen atom. See the picture 2, approaching hydrogen atom. What does it mean? Interaction begins. See the picture 3, the bonded atom. A bond is formed. Hydrogen molecule is formed by overlapping of hydrogen atom. Yes, greater the overlapping, stronger is the covalent bond formed. Who proposed valence bond theory? Yes, Hitler, London and Pauling in 1927. Valence bond theory used to explain the bonding and structure of the molecule. Covalent bond is formed by overlapping of half-filled atomic orbitals. That is, hydrogen combines with another hydrogen to form hydrogen molecule. That is 1s1 plus 1s1 gives 1s2. Strength of covalent bond is directly proportional to overlapping of atomic orbital. Orbital having same energy participate in the overlapping. The direction of overlapping is equal to the direction of bond and give the shape of the molecule. What is positive overlap or in-phase overlap? See the picture. PZ orbital overlap, that is 2 PZ orbital overlap. That is the wave function in the same direction and same orientation. The same phase overlapping is called positive overlapping. What is negative overlapping or out of phase overlapping? See the pictures. The PZ orbital overlap with another PZ orbital. That is different phase overlapping. That is positive negative overlapping is known as negative overlapping. The same orbitals PZ in the same orientation and different phase. Hence, it is negative overlapping. In positive overlapping, the same orientation and same phase. It is known as positive overlapping, that is positive phase. Then we pass on to what is zero overlap. See the pictures. When px orbital overlap with the s orbital, what is the overlap formed? That is different orbitals are out of the phase due to different orientation. That is direction of approach. This overlapping not help in the formation of bond. Hence, it is known as zero overlapping. Next, we pass on to what is sigma bond and pi bond in the overlapping of orbital. What is the term represented by sigma bond? Sigma bond is represented by a letter sigma. See the picture. It is head-on overlap or axial overlap. Can you define sigma bond? Yes. What is sigma bond and pi bond? When two half-filled atomic orbital overlap along internuclear axis. Such a bond it is known as sigma bond. What is internuclear axis? The line passing through the centers of nuclei of two atoms. It is known as internuclear axis. Can you give an example of sigma bond? Example, in hydrogen. One s orbital of hydrogen combines with another s orbital of hydrogen to form a sigma bond, that is along internuclear axis. Such a bond it is known as sigma bond. What is pi bond? When two half-filled atomic orbital overlap perpendicular to internuclear axis, the bond formed is known as pi bond. What bond is strong, sigma or pi bond? Give the reason. Sigma bond is strong due to maximum overlapping. It is a single bonded atom. Sigma bond is strong bond. What about the pi bond? Pi bond is a weak bond due to minimum overlapping. The pi bond contains double bond and triple bond. Yes, then we learn about sigma bond and pi bond. Sigma bond overlapping along internuclear axis. In pi bond overlapping perpendicular to the internuclear axis. Then we pass on to types of overlapping. What are the types of overlapping? SS overlapping, SP overlapping and PP overlapping. What is SS overlapping? Give an example. The mutual overlap of two half-filled orbital of hydrogen atom is known as SS bond. That is, in hydrogen molecule, overlapping of one hydrogen atom overlap with another hydrogen atom. What is the direction of bond? Along internuclear axis. Such bond it is known as sigma bond. Then what is sp overlapping? Give an example. When two half-filled orbital of one hydrogen atom overlap with the half-filled p orbital of fluorine atom to form sp overlapping. Example is hydrogen fluoride. That is, pz orbital overlap with the s orbital. The bond formed is also sigma bond, that is along internuclear axis. Then what is pp overlapping? Give an example. When two half-filled atomic orbital overlap to form pp orbital. That is, when two half-filled p orbital overlap to form pp overlapping. That is example in fluorine molecule, FF molecule. Here also the pz orbital, that is two pz orbital overlap along internuclear axis. In the same direction we have a sigma bond. Yes, in pz orbital overlap along internuclear axis. Hence such a bond is sigma bond. What type of bond formed in px, px and py, py in the different direction? When two half-filled p orbitals perpendicular to overlap, that is perpendicular to internuclear axis, the bond formed is pi bond. See the pictures of px, px and py, py perpendicular to internuclear axis. Such bond is pi bond. Hence, in p orbital overlapping along internuclear axis, that is pz orbital, when two pz orbital overlapping along internuclear axis, such bond it is known as sigma bond. While px and px, also py and py, when two half-filled p orbital overlap perpendicular to internuclear axis. Hence, two p orbital overlapping perpendicular to p internuclear axis, such bond it is known as pi bond. In short, all the three p orbital, one bond is sigma bond, that is in pz orbital, while px, px and py, py constitute two pi bond. Students, then we can do an assignment. Identify the positive and negative and zero overlap formed when A. Mixing px with the s orbital, B. Mixing px orbital with the py orbital. See the slide, see the pictures. When pz orbital overlap with s orbital, that is along internuclear axis, that is positive positive. Hence it is known as positive overlap in the same orientation in the same phase. Here also the pz orbital can overlap with the s orbital in the negative overlap. That means positive negative, that is in the same orientation but different phase. Hence it is known as negative overlapping. What about the question B? Mixing px orbital with the py orbitals. Both orbitals are different. Px orbital mixed with the py orbitals. The orientations are different and out of the phase. Hence it is zero overlap. The different p orbitals px and py overlap. There is no overlapping between px and py. Different orientation and out of the phase, hence it is known as zero overlap. Students, you have well learned about the terms, the valence bond theory, directional properties of covalent bond and overlapping, that is positive overlap, negative overlap and zero overlapping, and the type of overlapping, SS overlapping, SP overlapping and PP overlapping. Thank you students, learn well. We will meet the next e-content lesson number 10. Enjoy chemistry, enjoy and learn well. Thank you all.